Welcome to my Minecraft lessons. Today I'm going to tell you about an ABBA switch. I'm going to begin with a simple on-off switch. This is not an ABBA switch. I have a switch going through two repeaters, each going to a piston. Turn on the switch, the pistons activate. Turn it off, they deactivate. Because it happens so fast in the game, I made this graph so you can see what's happening tick by tick. As you can see, there is a switch in the bottom left. That switch goes into two repeaters. Each repeater is set to 1 tick. That's why there is one little red box in the lower right corner. I will be using other repeaters in this example, so I am going to call these specific repeaters the drivers. Each of these driver repeaters feeds into a device. It could be a piston, it could be a lamp. Whatever it is activated by a redstone signal. If we flip the switch, we can see what happens. Minecraft time works in ticks. In this first tick, the redstone signal propagates to each of the drivers. The drivers are repeaters, so they get charged. You can see that the first redstone lamp on the repeater charges up. I also indicate this with the larger square on the lower right. Because the 1 tick drivers are fully charged, in the second tick they move the signal through them and into the devices. As you can see, both of the devices lit up at the same time. You can see that the tick delay works in both directions, on and off. When I turn off the switch, in the first tick the redstone signal goes away going into the drivers, but it still exists in the output of both of the driver repeaters. During the second tick, the drivers are no longer sending a redstone signal and both devices turn off. I can toggle it on and off a few times so you can see how the redstone signal goes through the repeaters with a 1 tick delay and lights up both devices and turns them off at the same time. That is exactly what is happening in the game as I toggle the switch on and off. But what if you don't want them both to go at the same time? You can use a repeater to slow down the signal to the second driver. We can look at this in detail. Notice that there is another repeater in the circuit. It connects the input of the first driver to the input of the second driver. From now on, I will refer to these as the A driver and the B driver. This new repeater is set to 4 ticks. You can see there are 4 boxes at the bottom. It delays the signal moving forward from A to B. I will call this the forward repeater. Now let's turn on the switch. Initially, the redstone signal goes to the A driver and to the forward driver. On the second tick, the A driver is fully charged. It activates the first device. The forward driver has charged the second tick. On the third tick, not much happens. The forward driver charges 1 more tick. Next, the forward driver is fully charged and sends the redstone signal to the B driver. Finally, the redstone signal reaches the second device, activating it as well. You can see why device A turned on before device B. If I turn off the switch, it discharges in the same way. First, the redstone signal is lost from the A driver and the forward repeater. Then the A device is no longer active. The forward repeater loses 1 more tick. Now the B driver begins to discharge, and now everything is turned off. I can toggle this a few times so you can see it work. Now you can see why it's following the pattern A-B turning on, A-B turning off in the game as I toggle the switch. But what if you wanted to do A-B turning on, then B-A turning off? I simply add another repeater here. When I turn it on, A-B. When I turn it off, B-A. Looking at this in detail, You can see that there is another repeater that goes from the output of the B driver to the output of the A driver. It is also on 4 ticks. I called the first one the forward repeater. This one will be called the return repeater. When I turn on the switch, it starts activating the A driver and the forward repeater. On the second tick, the A device is turned on. The forward repeater moves to the second tick. Now the forward repeater gets one more tick, then the forward repeater is fully charged and sends a signal into the B driver. The B driver is fully charged. It turns on the B device and sends a signal into the return repeater. Even though both devices are turned on, the return repeater continues to charge. When I turn off the switch, it takes the power away from the A driver and the forward repeater. The A driver is fully discharged, but the A device is still being turned on because it is getting power from the return repeater. The forward repeater discharges, and then the B driver loses power. This turns off the B device and takes power away from the return repeater. In 2 more ticks, the return repeater completely discharges, turning off the A device. I can toggle this a few times so you can see how it works. Because it turns on A, then B, then turning off B, then A, it is commonly called an ABBA or ABBA switch. Now it makes sense why it works the way it does in the game. You are not limited to 2 devices. You can put many devices together in a long line. Each of the drivers is connected by a forward repeater and a return repeater. When you turn it on, it goes down the line in one direction. When you turn it off, they come back in the opposite direction. But notice there is a delay getting it to turn off. That is because we have to wait for all of the forward repeaters to discharge. Then when the last one discharges, the signal will go back through the return repeaters, shutting down each of the devices. There is a solution to this problem based on the fact that in between the repeaters and drivers, you can use any solid block that transfers a signal. Now with sticky pistons and solid blocks, I can immediately cut the signal at the end of the line. You only have to cut off the signal on the last half of forward repeaters. Then turning off your switch will immediately cut power, causing all of the return repeaters to discharge. Now there is no delay when you turn it off. Also note that you don't have to put it in a straight line. Here I have 3 devices, so I have 3 drivers. I have a forward repeater connecting the input of each driver, and I have a return repeater connecting the output of each driver, so I have an ABBA switch. And what is the point of all of this? There are many times when you need things to turn on in one direction and turn off in the other. This is an example. I have a 4-piston elevator. In order for this to work, I need the pistons to turn on A, B, C, D, and then turn off D, C, B, A. I'm sure you might find many other uses of an ABBA switch. That is pretty much everything you need to know about ABBA switches. I hope this was helpful. If you have any questions, please leave them in the comments below. Goodbye.